Video the turn off methods of SCR we will see. So here we must know the term called commutation. So what is commutation is it is a process to turn off the conducting SCR. So this can be achieved using the technique called while the SCR is on, so it is operating in forward conduction mode. So this area it is operating. So in this area it is operating. This is called forward conduction. So we must bring this forward conduction to forward blocking. This area we need to bring. So for that we have some technique called commutation techniques. So in which we merely brought the anode current below the holding current. Then we brought using some mechanism by which we must bring the anode current below the holding current. That becomes that time the SCR becomes turned off. For that different methods are there. The term commutation means transfer of current, conducting current to another path. It is called commutation. So the condition is that there will be a suppose you see. So here suppose this is a SCR. This is SCR. So the actual current is flowing like this. So this is called anode current. This is called anode current. So using some mechanism, we generate the current. That current is flowing just opposite to the anode current. Exactly opposite to the anode current. That time the current becomes zero. So this is the first technique they are following. So this the extra circuit that will generate the opposite current, that is called commutation circuit. Again the next one is by having some, suppose we have again the same thing, we have the same circuit. Using some extra circuit we develop the voltage just opposite to the reverse bias, that is minus and plus. Just we have some extra circuit. That circuit will generate the voltage. Minus is connected to anode and positive is connected to the cathode. That time it becomes a reverse bias. So this SCR is getting turned off. So using these two mechanisms, the first one is called making the current as zero, and the second one is making the voltage as a reverse biased. So by having extra circuit, these two conditions can be achieved. So those circuits we can call it as a commutation circuit. So what is commutation? Commutation is nothing but applying the reverse voltage that will commutate, that will turn off the SCR. So that may be forced. There are two broad classification. First one is forced commutation and the next one is natural commutation. We will see one by one. First we will see natural commutation. So what is natural commutation is automatically it is getting off. The conducting SCR is getting automatically off. That is called natural commutation. So the source of commutation voltage is the supply voltage itself is the commutation voltage. From the supply voltage this SCR is getting reverse biased, automatically it is getting off. That is called natural commutation. When the supply, so this is merely used in the AC supply. At every end of the positive half cycle, when the anode current goes the positive half cycle, the anode current goes to the natural current, that is current zero. So that times the SCR is getting off. So this method is called a natural commutation, applicable only for AC circuit. And if you see here you see the diagram, for positive half cycle the SCR is forward biased, the current is flowing like this. At one point at the end of the positive half cycle the current becomes zero. So that time the SCR is getting off. Again during the negative cycle it won't conduct because it is reverse bias. It won't conduct even though we give the gate pulse to this triggering pulse to this gate, it won't conduct. That is called natural commutation. And under the category of forced commutation, this forced commutation is applicable to the DC circuit. Here there is no natural current 0. There is no natural, as like a previous case, the current becomes naturally 0, but here we are making current as 0 using extra circuit called a external circuit. That circuit we will be called as a commutation circuit. This commutation circuit will make the conducting current as 0. This again, this commutation circuit consists only inductor and capacitor combinations. So those components will be called as a commutating components. So inductor and capacitor are acting as a commutating components in the forced commutation circuits. So forced commutation is classified into different categories based on the way by which the current becomes 0. So the first one is class A, class B, class C, class D, and class E commutation. So this forced commutation circuit is purely applied only to the chopper circuits, that is a DC chopper circuit and inverter circuit. These commutation circuits are very much used. So first one is natural commutation. So this natural commutation, otherwise called self commutation, resonant commutation, or load commutation. So this load commutation, this load will be acting as a commutating voltage source. So here if you see the load, here we have the load, this is a load. So this load will be acting as a commutating voltage. This load will be acting. Suppose you see, when we turn on, by giving the gate supply, this SCR is getting turned on, so there will be a current flow. So while the current is flowing, the inductor is getting charged plus and minus. After some sufficient time, this plus voltage is connected to the cathode. Plus voltage is connected to the cathode, that is which is very much higher than, which is slightly higher than the supply voltage. So at that time this SCR becomes a reverse bias. So once this is reverse bias, it is getting automatically 0, automatically off. So that is called a class A commutation, called a resonant commutation or load commutation. So this load will be acting as a commutating voltage. And again we have the class B commutation. Again this is also called as a self commutation. So here suppose when the SCR is getting turned on, there will be two current flow. There will be two current. One current is flowing like this, and another current is flowing like this. One current is flowing like this, another current is flowing like this. So when sufficient voltage increases to the capacitor, after some time this capacitor will discharge. Right, we will change the color. This capacitor will be discharging like through this transistor SCR. It will be discharging like this, causing keeping the voltage plus in the bottom side and minus in the upper side. So this, after sufficient amount of time, this plus is connected to this chargeable voltage. The polarity of the capacitor is plus downside plus upside minus. This plus is connected to the cathode and minus is connected to the anode. That will cause this SCR as a reverse bias automatically getting off. So this is called a class B commutation. And a class C commutation, that is called a complementary commutation, in which we have two sets of SCR. One for two set of SCR, one is called a SCR1 and another one is SCR2. So this is the explanation of this commutation, class C commutation, mode 1 until mode 2. First, in mode 1, SCR1 is the main SCR. Suppose this SCR is conducting. So there will be two current flow. One is current flow is like this, and another current flow is like this. So in this direction, through this resistor, this capacitor is getting charged. capacitor is getting charged with the left side plus and right side plus, left side minus. Like this it is getting charged. After some time SCR2 is getting triggered. This voltage, negative voltage in the capacitor is connected to the is given to the anode of the SCR, anode of the SCR, causing reverse bias. Automatically it is getting off. So therefore the same process is getting repeated when SCR2 is conducting, which can be turned off using the SCR1. So this is called complementary commutation, called class C commutation. And we have the commutation called a class D commutation. So this is called auxiliary commutation. This can be otherwise called auxiliary commutation. So SCR1 is the main device and SCR2 is the auxiliary device. So this is called auxiliary commutation. So initially this the circuit can be explained at a different modes, but we will see very quickly. Let us assume that this capacitor is charged with plus minus. The polarity of the capacitor is like this. So when SCR1 is triggered, there will be a current flow like this. There will be a load current flow as a green color, and we have one more current that is called a commutating current. So it is going like this. So this red color, when the red color current is flowing, inner current, that will charge the capacitor with plus minus like this. Like this it is, we have the bottom one is plus and the upper one is minus. So this is the direction of current. Now after some sufficient amount of time, at that time I want to turn off SCR1. So when I want to turn off SCR1, we need to trigger SCR2. So since already this SCR2 is forward based using this capacitor voltage, so there will be a current flow. Let us take a, there will be a current flow through this SCR2 from the load. So this voltage, the voltage of the capacitor, top one is minus and the bottom one is plus. That is directly applied to the SCR. That is, minus is connected to the anode and plus is connected to the cathode. So thereby this SCR1 is the reverse biased. Automatically it is getting off. So this is called a class D commutation. So this commutation technique applied to the chopper circuit. Those chopper circuit we can call it as voltage commutating chopper. So in that case we will see very detailed manner. It has 5 modes of operation, each mode having its own significance. So that we will see later. And the last one is called a class E commutation. Using some external pulse, we are making some commutation. So this is an external pulse. This pulse generator will generate the pulse using isolation transformer, which is given here. That will apply some current, that will generate some minimum value of current, just that is opposite to the original current. So when these two currents original current and pulse generated current both are equal, so that time the current becomes zero. So this is called a external pulse commutation circuit. So like this we have different ways of a commutation circuit from class A to class E. Thank you.